Welcome. In this session, we will talk about how we can integrate data and software engineering to improve the development process. This video will focus on PoolParty use case as part of Aligned project. The main goal of this use case is to improve the development process of PoolParty software components by aligning management of data issues and software development process to support each other. PoolParty is a semantic technology suite that offers solutions for knowledge organization and content business. The various components of PoolParty are taxonomy and ontology server, entity extraction and text mining, data integration and data linking. Data in PoolParty projects are created either by application itself or by user importing data as files. So, the data inconsistencies in PoolParty projects are caused by application errors or can be introduced by user importing data into the project store. To organize the process of requirement collections, feature specification, and tracking of development data, Semantic Web Company uses Atlassian tools, Confluence, and Jira. To manage software development artifacts, we transform the development data as RDF. The data is annotated with concepts using the PoolParty knowledge graph thesaurus. A faceted search is built on top of this development data, which helps in identifying requirements related to issues or detecting duplicate issues. PoolParty ensures that the data produced by application itself should be consistent. User importing the data in PoolParty is validated and repaired using PoolParty component. When implementing a new component in PoolParty, the developer needs to design data model and implement components that produces consistent data. This diagram shows a system architecture of PoolParty use case. The RDF validation is based on RDF unit and integrated into PoolParty is used to support data consistencies for application by providing constraint checks and repair strategies. Issue integration feature is used to report issues in PoolParty to the PoolParty support administrator. A unified views pipeline is built to harvest data from Atlassian tools, Confluence, and Jira and transform it into RDF using aligned vocabularies. A semantic search is built on the development data for identifying related requirements and issues. By evaluating the result of these semantic search, we can detect that some validation check is missing in PoolParty and implement a new validation check. The first component is RDF validation, which is integrated into PoolParty to support consistency within the application data storage. The RDF validation can be used to check and repair data that we want to import into a PoolParty project. Data within PoolParty projects has to satisfy constraint for the application to work correctly. To ensure that the imported data does not violate these constraints, RDF validation is used. If violations are found, the user has the possibility to apply repair strategy and correct the problems. But if there is an inconsistency happen after performing the validation, it may be because of the bug in application and we need to add a new feature or additional check to ensure the consistency of data. We will see more about that in our demo. This is the PoolParty application. To see if data is consistent in this project, click on Quality Management and then click on Import Assistant and check existing data. You can see the list of constraints that are mandatory to conform with PoolParty to operate normally. Each check also defines repair strategies that can be applied to fix the violation. When all the violations are repaired and conformance is achieved, the user can transfer the imported data into the project without the risk of application failure caused by inconsistent data. Data inconsistencies in PoolParty can be caused by application error or can be caused by a user while importing data in PoolParty without performing the constraint checks. These type of inconsistencies, which cannot be handled by PoolParty, can be reported to PoolParty support by using the issue integration feature. The issue integration feature is integrated in PoolParty project, which allows user to automatically create Jira support tickets whenever an internal error occurred in the application. We will see more about that in our demo. The semantic middle configurator of PoolParty allows the user to create a Jira instance by stating the URL, the project key, the number of log lines, and the user credentials. So when I import an RDF file into the PoolParty project store, the import assistant will check for all the constraints necessary for the application to work correctly. The import assistant found some violation which may cause an application failure. But if the user still tries to store this data into the project store without fixing this issue, it may cause an application failure. So if I click there, it causes application failure. Then the user can report this issue to the PoolParty support by stating some title and optionally attaching the RDF file. In this way, an issue can be reported to the PoolParty support. Unified Views is an ETL tool for RDF. We created a Unified Views pipeline for harvesting data from Confluence and Jira and transforming it into RDF using the DO ontology. The data is then annotated with the PoolParty knowledge graph thesaurus, which helps in calculating the similarity scores among issues and requirements. We have defined different data processing units in this pipeline. The eConfluence Jira extractor DPU extracts the Confluence and Jira data and transforms it into RDF using the DO vocabularies. The concept extractor DPU annotates the data using the PoolParty knowledge graph thesaurus. The similarity DPU computes similarity over this development data. For this use case, we are calculating lexical and graph-based similarity. Finally, the HTTP loader DPU loads the data in the triple store. Graph search is a faceted search built in development data is used for managing development artifacts. We integrated similarity results from Unified Views pipeline into the graph search to find duplicate bugs. This also helps us in finding stories which are related with a specific bug or requirements which are related with a specific bug. This is the graph search application. On the left hand side, you can see the facets on basis of which you can search over the development data. For example, if I select an assignee with a specific issue type, I can only see bugs here. So if I click on a specific issue, I can see the details about this issue, what is the priority type of that issue, who is the reporter, what's the status for that, and so on. On the right hand side, you can see different similarity algorithms implemented for this use case. Graph-based similarity is basically based on the PoolParty thesaurus annotations, and it's the improved version of the lexical similarity. So if I calculate the combined similarity between this issue and the other issues, I can see different bugs and stories and ideas, issues which are related to this issue. So if I click on that issue, I can see that this issue talks about the password validation, and that issue also talks about the password validation. So in this way, you can find the related bugs with each other. So when we analyze the bugs, we can see that a component was modified resulting in inconsistent data, or component was modified and a new check is required, or a new component is introduced and requires an additional consistency check in the application. Thank you for your attention.